Boys and girls, welcome back. We are doing last set of examples of congruency. So I just have drawn three sets of triangles because I want to show you something when proving the congruency of triangles. So like I've mentioned earlier that we have got four different conditions of proving congruency. So now I'm going to deal with a condition of angle, side. All right, so boys and girls, I want you to know something. You must always work with the information that you are given. So let us look at these two triangles. All right, so what do I have? I have obviously every triangle has got three angles. So but then now I have got an information that I am given. That angle B is equals to angle E, and angle C is equals to angle F, and side BC is equals to side EF. This information is given simply because of these dots that I have here. Not all the time that you will be given this information. Sometimes you just have to apply your geometrical knowledge. So, but on this information in particular, we are given that information. Okay, so looking at that, I've already said an angle is equals to an angle that satisfies this fact. Another angle is equals to another angle, satisfy that, and side BC is equals to side EF. Then we satisfy that condition. Remember, guys, you can write it as SAS or SSA. Really, if you wrote it like this, the next person like this, and the next like that, they mean the same thing. Okay, so I just want us to note a very important fact here. Looking at these two triangles, the angles are situated at the same position. If you can see that this dot here is corresponding to the position of the dot there, and this curve or arc here correspond with this one, this side, and then the side there correspond with that side there. So I just want to clarify you on the misconception that most people do. Let us look at the set of the second set of triangles. If you can look, this dot is here, and on this triangle a dot is there. Are they situated on the same position or relative to the side? No, they are not. Therefore, this already tells us that these two triangles cannot be congruent simply because the position of the angles that are supposed to be corresponding are not in the same position or are not corresponding. And then the side might be corresponding, this side corresponds with this side, but this angle and this angle are not corresponding. This angle is corresponding to that side, and but the fact that this one is not corresponding with that one, it proves that those two triangles are not congruent, because for triangles to be congruent, satisfying this condition, it says that two angles and a corresponding side of two triangles are equal. Therefore the triangles will be congruent. All right, and then one other fact that I want you to note, listen attentively. When we are using AAS, or this, which is SAS, is same as AAS, okay? To prove congruency, the angles must be in the same place relative to the side, relative to the equal side. Can I read that again? When using this to prove congruency, the angles must be in the same place relative to the equal side. So it means for these two triangles to be congruent, this angle should have been there. So the fact that it's not there, then they are not congruent. Similar example, we have got a side here and a side there. We've got an angle there and an angle there. So looking at that, they are not in the same position, and that fact means that these two triangles cannot be congruent. I hope that you will know the difference between these 3 triangles. Okay, boys and girls, with all that said, let us go and prove our congruency on these 2 triangles that we are given. So remember, guys, you must always work with the information given to you. They are saying that in triangle ABD and ACD shown above, angle A1 is equals to angle A2. Hooray! They gave us information. Isn't it nice to just be given information? Then you don't have to worry much about a lot of things. So now they say if AD is perpendicular to BC. Let us address this word. Perpendicular. What does it mean when they say that lines are perpendicular? When they say lines are perpendicular, this simply means when 2 lines intersect, at their point of intersection, an angle of 90 degrees is formed. So it means that here an angle of 90 degrees is formed when 2 lines intersect. For instance, on this we've got AD. It crosses to intersect just to where they meet. Yeah, when they meet AD, when it meets BC, an angle of 90 degrees is formed. You can see that we've got 90 degrees there and 90 degrees there. Okay, so they are giving us this information is very important, guys. When you're given information like that, then you must be excited, because now you already know that a particular angle is equals to 90 degrees. Okay, which in this case, that very one, D, is equals to 90 degrees. Okay, so finally, they say that prove that triangle ADB is congruent to triangle ADC. Okay, did I read that right? Yes, they say triangle ABD. Prove that triangle ADB, okay, is congruent to triangle ADC. Yes, I wrote that right. Okay, let us start. Always work with when you're given information, start with it. Why waste time? So you're just going to say angle A1 is equals to angle A2. Why? Given. Okay, and we are moving on, and we go to angle D. Do you see that angle D? Angle D. Actually, we have got 2 angle D. They just did not mention, like, did not write angle 1, D1 and D2. But we've got an angle this on this side, and then we've got an angle D on this side, which means that both of them, they are equals to 90 degrees. So we can say that angle D is equals to angle D is equals to 90 degrees. And what is my reason? My reason given is that AD is perpendicular. This is how you write perpendicular. One thing that I love about math is that you don't have to write long words. So this is the sign of writing perpendicular. They said angle side AD is perpendicular to BC. Perpendicular to BC. Well done. And then now you are concluding. And then what else do we have? We spoke about angles. We spoke about these 2 angles. We spoke about these 2 angles. Can I say something about this side? Can I say something about this side? I don't have information about that, but I for sure have information about this side, which is AD. It is shared between this triangle and that triangle, so I can use it to say they are equal because it is a common side. So I can say side AD is equals to side AD. Why? It is a common side. It is a common side. And therefore I can conclude that triangle ADB is congruent to triangle ADC. Why? I used angle side. And say angle side. I hope that is visible, boys and girls. Now let us try another example. Let me just shift the camera in a way that we can all see. Great. Okay, then it means I must, sit like this. All right, we have got a nice two triangles there, which are congruent to each other, I believe. They are saying in triangle ABC and triangle DCB, AC is equals to BC if AB and DC are perpendicular. That word comes again, are perpendicular to BC. Prove that triangle ABC, triangle ABC is congruent to triangle DCB. Okay, so what I did for myself here, so that I can be able to see these triangles properly, I redrew them and then I separated them. So if you can see, I said A, B, C. I redrew it as A, B, C, so that I can see it. Yeah, you have to do what you have to do to understand, right? And then I said triangle DBC. I redrew it so that I can be able to see what is going on there. So they told me that AB and DC are perpendicular to BC. So you can see that this and this, they intersect. Where they intersect here, see, AB intersects here. Then an angle 90 degrees is formed. Did you see that? Okay. So now let us prove. I must always work with the information that I am given. Okay? This is what I'm going to do. First of all, angle B and angle C, or angle B. Here, I redrew it, angle B and angle C. Both of them are equals to 90 degrees. So therefore, they are equal. So I'm saying angle B is equals to angle C is equals to 90 degrees. 90 degrees. Why am I saying that? It is given, first of all, it is given. But you can also write that, AB is perpendicular. AB is perpendicular to BC and DC to BC. And DC is perpendicular, DC is perpendicular to BC. And I said AB is perpendicular to BC. Yes, because where they meet, where AB meets BC and 90 degrees is formed. And then where DC meets BC and 90 degrees is formed. That is why we are saying they are perpendicular, guys. And now I'm continuing. I've got two sides. I've got AC and BD. They are equal. Why are they equal? They are all hypotenuse. AC is equals to BD. Why? Hypotenuse side. Hypotenuse side. All right, and then I'm going to say BC is equals to BC. Why is BC equals to BC? Because BC, it is shared between the triangle ABC and DBC. So I'm going to say BC is equals to BC. It is common, BC and BC. It is common. So I'm going to say it is a common So now I'm going to conclude. I don't have space here, so allow me to conclude here. So I'm just going to say, therefore, triangle ABC is congruent to triangle DCB. So now, boys and girls, we are using another for condition, which says right hypotenuse side. This is for a special. This is for special triangles, which are right angle triangles, simply because we have a reason where we spoke about hypotenuse. So I must indicate that I use a right angle, hypotenuse, and a side. And therefore, with all that said, we have proven that these two triangles are congruent. I really hope that it makes sense and you will win at this.